This is question number 43 of GATE 2020 from the subject of Process Fluid Mechanics from Chemical Engineering Department paper. The question is given as liquid water is pumped at a volumetric flow rate of 0.02 meter cube per second from tank 1 to tank 2 as shown in figure. Both the tanks are open to atmosphere. The total frictional head loss for the pipe system is 1 meter of water. Then we have been given this information related density of water, acceleration due to gravity, efficiency of the pump. And we have been given that the liquid surfaces in the tank have negligible velocities. The power supplied by the pump to lift the water is dash. The power we have been asked to find. So let us consider this system in which we are having two identical tanks, tank 1 and tank 2. So tank 2, we can see that it is filled up to this 5 meter, and similarly this height is will also be 5 meter, considering both these tanks is identical. Now we have been given that the pump is taking the fluid from tank 1 from point 1 and delivering it to point 2, that is the inlet is at 1 and outlet is at 2, and we have been asked to find the power of the pump given the total frictional head loss for the pipe system is 1 meter. That is summation of all the frictional head loss is 1 meter of water. Now we can write the Bernoulli's theorem for this system between this point 1 and point 2. That is, we can write this as P2 minus P1 upon rho is equal to G plus G. If this is height 2 and this is height 1, then we can write it as H2 minus H1 plus 1 upon 2 V2 square minus V1 square plus summation of frictional losses plus work done is equal to 0. Now in this question, we haven't been given any information about the different cross-section area of the pipe. That is, we can consider that the pipe diameter will remain same. So the area of cross-section of the section at the inlet and the outlet will remain same. That implies that using the continuity theorem, rho 1 A1 V1 is equal to rho 2 A2 V2, we can write that both the velocity will remain same. That implies we can straight away cancel out this term. Now let's just calculate the pressure at point 2 and point 1. So over here at point 1, we can write the pressure P1 as atmosphere pressure is acting in this direction. So at point 1, it will be PA plus rho GH and height is 5 meter. That is P1 is equal to PA plus rho G into 5. Similarly, P2, that is the pressure at this point, will also be PA plus rho G and height is 5 meters. So it will remain the same. So basically P1 is equal to P2. That implies we can also neglect the first term. And now we are left with this equation, that is G H2 minus H1 plus half this we can neglect, summation of F plus work done is equal to 0. Now let's just replace all the values with the units, and we will be having G is 10 meter per second square, height is 5 meter plus force we have been given in meter. So basically we will be multiplying it by G again. Okay, so over here there will be G, so we can convert this into meter square per second. So it will become again 10 meter per second square into 1 plus work done is equal to 0. That is, we have been given, wait a minute, So over here, we have been given the gravitational constant as 9.81. So instead of 10, we will just write it as 9.81. So it will become 9.81 into 6 is equal to minus of work. So 9.81 into 6 will be around 58.68, and this will be in joule per kg. So the work done by the pump will be 58.68 joule per kg, and we have been asked to find the power delivered. That is power, we can write it as mass flow rate times of work. The mass flow rate, we can calculate it from rho AV into work done. Density of the water is given as 1000 kg per meter cube. And then AV, basically the volumetric flow rate. Over here we have been given as 0.02 meter cube per second. It is 0.02 meter cube per second, and this was kg per meter cube. Work done, we calculated it as joule per kg. This will get cancelled out. Basically we are left with work done was 58.68. That is 0.02 into 58.68 into 1000 joule per second, that is watt. So we can simplify this and it will be 1173.6 watt. The power delivered by the pump to lift the water from this height, tank 1 to tank 2, is 1173.6 watt. So the final answer, we can write it as 1173.6 watt.